Welcome! Today we're taking a look at national drinking water standards. We're going to take some incredibly dense, highly technical regulations and translate them into a clear, actionable playbook. Whether you're managing a facility, working in local government, or you're just curious about the infrastructure right under your feet, this overview is built to give you the exact framework for how our drinking water is actually kept safe.
But real quick, let's just pause and think about something. How do you actually know the water flowing out of your tap is safe? Right? Every single time you turn on the faucet to grab a glass of water, or boil some pasta, or brush your teeth, you're relying on this massive, totally invisible safety net. It's working 24/7 to make sure the water you use every day doesn't make you sick. So let's dive into exactly how that net is put together.
Here's our game plan for today. We're breaking this down into 5 parts. 1. Why safe water matters. 2. Setting the safety limits. 3. Testing and monitoring requirements. 4. The lead and copper rules. And finally, 5. The consequences of rule violations.
All right, kicking things off with Section 1, Why Safe Water Matters. Before we get into all the heavy compliance metrics, we really need to ground these rules in their actual purpose, protecting human health.
Because at the end of the day, the human element behind all this paperwork is what absolutely matters most. These rules, they aren't just bureaucratic red tape. They exist because contaminants in water have really severe, often irreversible effects. We're talking about protecting our most vulnerable people: infants, young kids, pregnant individuals. Exposure to certain metals or microbes really early in life can literally cause lifelong developmental delays, cognitive issues, and serious physical illness. That is the core why driving every single thing we're going to talk about today.
Moving right along to Section 2, Setting the Safety Limits. We know why we need safe water, but how does the government actually decide what counts as safe?
Okay, so there's a really crucial difference here between a theoretical goal and a practical law. In a perfect world, we'd have an ideal health goal where absolutely zero harm occurs. Which sounds great, but scientifically and economically, it's usually impossible at a citywide scale. So instead, we have the enforceable safety limit. This is the strict, legally binding maximum amount of a contaminant that a water system is allowed to deliver to you. Regulators set this hard boundary by balancing that perfect ideal with the reality of current treatment tech and what it actually costs to run it.
But not all water systems are the same. Protecting a massive city grid is obviously completely different from protecting, say, a single office building. So the regulations split facilities into categories. You've got community systems. These serve year-round residents, so think of your average town or suburban neighborhood. Then you've got non-community systems. These serve specific transient populations, like a rural school with its own well or a remote corporate park. The basic safety rules apply to everyone for sure, but the administrative stuff flexes depending on who the system actually serves.
So what exactly are these utilities hunting for? Well, they're constantly screening for a few main categories of invisible threats. First, you've got microbes, viruses, and parasites that can make you sick immediately. Second, inorganic chemicals, like heavy metals, such as lead and copper. Third, organic chemicals, which usually come from agricultural or industrial runoff. And finally, disinfectants. Yep, even the chemicals like chlorine that are used to kill the microbes have to be strictly limited so the leftover residue doesn't end up harming you.
Which brings us to Section 3, Testing and Monitoring Requirements. If they know the limits, how do utilities actually prove they're hitting them? Think of a municipal water system like a giant factory line. It needs relentless quality control. The water is monitored at 3 main checkpoints. First up, the source water. They sample the raw river, lake, or aquifer just to know what they're dealing with. Next, the treatment plant. They check the water as it goes through the filters and disinfection machinery to ensure the gear is actually doing its job. And third, and this is a big one, the consumer tap. They pull samples right from the endpoint to prove the water didn't pick up any gross stuff while traveling through miles of underground pipes.
Now look at this number, 99.99%. That is the percentage of viruses that surface water treatment plants are legally required to neutralize or completely remove. They also have to hit a 99.9% reduction for those really stubborn parasites. I mean, that just shows you how astronomically rigorous these standards are. Mostly clean is legally unacceptable. It practically has to be sterile.
And they can't just test this stuff whenever they feel like it. It's not random. They operate on these highly structured, mandatory compliance timelines. The whole rhythm of the regulation runs on a 9-year cycle, broken down into strict 3-year periods. Facility managers literally have to track their sampling schedules against these exact periods, or they face some really severe penalties.
All right, let's shift gears to Section 4, the lead and copper rules.
This is, without a doubt, one of the most critical and heavily enforced pieces of the entire framework.
0.01 milligrams per liter. That is a tiny, microscopic decimal, but it's the strict regulatory action level for lead. If a system detects lead over this minuscule threshold at the tap, boom, it triggers an immediate aggressive crisis response. It is a literal tripwire built directly into the law to make sure heavy metal contamination is stopped the exact second it's found.
But how does lead even get in there? It's usually not from the source water. It's leaching from the pipes themselves. That's where corrosion control steps in. It's actually a pretty fascinating process. The utility actively adjusts the chemistry of the water, like tweaking the pH levels, so that the water essentially coats the inside of the pipes. That coating stops the water from acting like a mild acid and slowly dissolving toxic metals out of the old plumbing.
Now, if a facility trips that lead threshold, they don't get to just wing it and guess how to fix it. They have to follow an exact, mandatory 5-step playbook. Step 1, immediately monitor the source water. Step 2, formally recommend a specific treatment plan. Step 3, get the state environmental agency to review and approve it. Step 4, actually install the new treatment tech on a strict timeline. And Step 5, do rigorous follow-up testing to prove the fix actually worked.
And honestly, one of the biggest game changers in the recent updates to these rules is this. Ignorance is no longer an excuse. The law mandates comprehensive public line inventories now. Water systems have to actively investigate and map out the material of every single service connection in their network. And get this, they have to do it even for the parts of the pipe owned by the private homeowner. They have to hunt down these hidden hazards before anyone gets hurt.
So, what happens if they drop the ball? Let's jump into our final segment, Section 5, Consequences of Rule Violations. Because let me tell you, the state does not mess around when it comes to these standards.
The very first consequence is the ticking clock. Deadlines for notifying the state are incredibly rapid and unforgiving. Got a severe bacterial risk like E. coli? You have exactly 24 hours to report it. Fail a general chemical standard? You've got 48 hours. And even if you just accidentally forget to run a routine test, you have a maximum of 10 days to confess that monitoring failure to the regulators. And the penalties for failing are massive. For instance, if a facility repeatedly fails its lead tests, like 3 times in a 5-year period, they are hit with mandatory mitigation actions. The utility is legally forced to physically hand out pitcher filters to their consumers. They have to supply 6 months' worth of replacement cartridges, deliver state-approved instructions, and run aggressive public health campaigns. Just imagine the logistical nightmare and the cost of doing that for an entire town. It's a huge incentive to just stay in compliance in the first place.
Ultimately, the whole philosophy behind this framework is total transparency. The law strictly forbids hiding a failure. If a system breaches a safety limit, they are mandated to immediately broadcast that failure to the community. They have to outline exactly what went wrong, what the health risks are, and exactly what they're doing to fix it. It's the ultimate accountability measure.
Which leaves us with a final thought for today's briefing. Think about your own neighborhood for a second. If a state inspector walked into your local water utility today, what would they find? Would they find a system proactively managing its chemistry, mapping out its pipes, and fiercely protecting your health? Or one that's just crossing its fingers and waiting for a violation? Now that you understand these rules, you actually have the power to ask the right questions about the water you interact with every single day. Thanks for joining me, and stay curious.
If you found this helpful or want to stay updated when this regulation changes, subscribe and support the channel. And if you need the full technical details on this CFR, click the link in the description below. See you next time.